option one would be to first multiply and then take a derivative. And the second way is to use product rule right now and take a derivative. Do you see this one way or another when you look at this? Like multiply in, then take a derivative, or just use product rule for the derivative?
I don't know, to be honest.
Okay, well, you're the one taking the test. This is me asking you how you see it, because I
would just do product rule.
Okay. Now, do you need to write out like F and G, or can you do it as you go? Where are you at with your comfort level on product rule derivatives?
Usually I write out the F and G.
Okay. All right, so F, we'll call e to the X, derivative is e to the X, X cubed minus 3, and then 3X squared. When you form the product rule derivative, okay, it's good if you can do more simplifying as you go. Like I think one of the real challenges of calculus is all the algebra and the manipulation of stuff that maybe you're not used to. Because it would be even better if you could just sit here and be like, oh, it's 3x squared e to the x plus e to the x times x cubed minus 3. If you could go right to this line rather than writing it as a product, but really depends on your comfort level with that. There's not a wrong answer here. Now, when you look at the answers, and I do think it's good to kind of do it without the answers, at least to start, so that you're not influenced by them. And now you guys start looking and be like, all right, well, which one kind of is my answer? And you kind of notice, okay, well, C kind of looks right, but not sure. You might be able to say, okay, it's not D. Notice though, there's no parentheses in your answers, so you will have to distribute this e to the x to both. So 3x squared e to the x plus e to the x cubed, or x cubed e to the x minus 3 e to the x. And then you're going to say, oh, there it is. There's my derivative.
Wait. How did it simplify to just that?
So the previous line, you're taking e to the x and multiplying into each of these.
Yes.
So I'm just suggesting you might want to rearrange e to the x cubed as x cubed e to the x.
I thought that was the final answer for a second. I got really confused.
There's a preference in math to put polynomials before exponentials. I don't know why, but that is the preference. So you just do things the way that you see.
So it's A.
It is A. All right, number 3 is a good one for you to try on your own. It's kind of got all the derivative rules in there that are kind of the mixture of them. Like maybe you sit there and say, oh, I know x to the 5th, 5x to the 4th. Well, they all have 5x to the 4th in there, so that doesn't help. So really it comes down to like you remembering how to take a derivative of 5 to the x and e to the 5x. So we give that a try, please, and let me know if you have any questions.
Is it D?
It is D, yes. Okay, so that's a nice problem to see that you've got your rules down. All right, so before we do 4, the one of the things that will help you speed up your derivatives is to remember that d dx, the derivative of the square root of x, is 1 over 2 square root of x. I know that typically you write it as like x to the 1/2, Then you bring the exponent down and subtract 1. If you can remember this, it will save you a lot of time, especially on the AP. They seem to really emphasize that. So that does apply to this problem here. So the way it applies is that because the square root is the outermost function, your
Mhm.
derivative is going to become 1 over 2 square root of cosine 2x. And then the chain rule requires you to now take the derivative of cosine 2x. But if you can, if you can remember this, you can at least sort of potentially eliminate some answers here. You do want to keep going with your derivative of cosine. Do you remember the derivative of cosine? Yes,
Wait,
no.
so what do we find the derivative of?
Well, I'm trying to save you from having to write this as cosine 2x to the 1/2 power. And using the power rule. I'm trying to show you this shortcut for taking the derivative of square root that you will use over and over again, not just in this course, but in others. It's always 1 over 2 square root of whatever's inside the square root. If you don't like that, we got to do power rule followed by
Oh,
chain.
no, we can do that.
Okay. The chain rule, though, is what I'm asking for now, the derivative of cosine 2x. Because we've only taken care of the derivative of the outermost function.
It would be 2 sine 2x, 2 negatives, negative 2 sine.
Yes. Okay, so a couple things you might notice is now there's finally a negative in the problems. That means that A and B are out. Really couldn't eliminate any quite yet. The 2's do cancel, and that's the only difference between C and D. And there you have it. As always, if you want one like any of these, I'm happy to make one up that's similar, but that's obviously at your discretion here. All right, let's look at and by the way, these are not AP quality questions. These are like leading into AP quality questions. These must be from a website or like a weekly practice to get you ready, but they're never going to be this. These are too easy for the AP. But nevertheless, they're still important to do. They lead to AP type questions. So when you look at something like this, do you see, there's a bunch of rules. There's like power rule, product, quotient, chain rule. There's just straight functions. Like, what do you see when you look at something like this? What's jumping out at you?
Well, I would do like 5x squared minus 3 to the negative first.
Yes, so you're going to use power rule, and that's a good way to do it. All right, so why don't you try doing this problem and let me know what you come up with.
Would it be negative 10x? It'd be C.
It is C. Very good. All right. 6. Okay, 6 is kind of got something to it here. Okay, so before I grab 6 here, there's this progression that I hope you've seen in class, which is if you start with sine and you take its derivative of sine t is cosine t, derivative of cosine is minus sine t, and the derivative minus sine t is minus cosine t, but then it goes back.
Mm-hmm.
Okay, so the idea is that if you think of the derivative like this is the first, second, third, and then so what some students do instead of kind of wrapping it around here, it really depends on which one you start with, but you can say 4 is sine t, but then you get 5, 7, 8, I'm sorry, 5, 6, 7, and 8, and this pattern repeats. Right.
Mhm.
So the reason I bring that up, a reason that's important here is r of t equals sine t. They're asking for the 14th derivative. You don't want to write 14 derivatives. You want to know the pattern though. You want to know, okay, where does 14 fall on this list? So you'll see students just sit there and count. They're like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's this one right here. All right. The other way to do it is to take that exponent, divide it by 4, which is 3, but what you really want is the remainder of 2. The remainder tells you which one it is. This is remainder of 1, remainder of 2, remainder of 3. This is remainder of 0. That's, if you recall, you probably did some problems like, what's I to the 5,089 power?
Yeah.
It's kind of like that. But we're not completely done because you have to evaluate it. You have to evaluate minus sine of pi over 3. This is where you have to know your unit circle. You have to say, okay, where am I on the unit circle? Well, pi over 3 is up here. Is sine the x or the y value there?
Can you repeat the question?
Yeah, the question is, if you remember on your unit circle, is
Oh,
sine
it's
the x?
y.
It's the
The
y
y
value.
value.
Yeah, so sometimes you can't like remember which one is it, but if you remember that it's the y is further up. It's square root of 3 over 2, but because you want negative sine, it ends up being negative square root of 3 over 2.
Okay.
The one really good thing about this practice is that your multiple choice answers are very deceptive, and they have encoded in them a lot of wrong answers that you might get. You got to be really like on top of it to do this.
Mhm.
All right. This one says to determine the 4th derivative of x and then evaluate it at -2. It's similar to the previous one in that there is like a pattern that you notice, but I think it's just a first time calculus student. You're probably going to want to actually just take each derivative and
Okay.
get down to the 4th one. But by the end, you're going to say, ah, maybe I should have known it was just that. So go ahead and give this one a try, please.
The 20. Is it A?
How did you come up with A? What is your 4th derivative?
24x plus 6.
Okay, so first derivative is 4x cubed plus some other stuff. Second derivative is 12x squared. Third derivative is 24x. Fourth derivative is 24. And yeah, there's
I
some other
think
stuff.
yeah, I had to go one more.
Oh, you know what? I missed. I'm wrong. I'm wrong. They're giving you the first derivative, which is weird. I don't know why they would do that. I guess just to be deceptive here. So I'm wrong. It is 24. The 4th derivative is the 3rd derivative in this progression, which is the 24x plus 6, which is letter A. Yes. So the first derivative that you take is really d squared y over dx squared. The second derivative is really d cubed y over dy squared. Third derivative is really d4y over dy to the 4th, or dy. Yeah. Sorry, this is cubed, 4 and 4. Right. So lots of derivatives. Lots of derivatives. I know you sent something else over. Is it on integrals or is it unrelated?
There's 8 of these review things.
Wow. Okay. All right, given the relation, that's important. It's actually not a function. It's some sort of thing that might overlap onto itself or something, the graph of it. They want you to determine the slope of the tangent line to the curve at 1, 2. So what they're asking for here is the derivative, dy dx, evaluated at 1, 2. So whenever you see x's and y's, you say, okay, that's an implicit derivative. Do you remember implicit derivatives from earlier in the course?
Yes.
Okay, so the derivative here of x squared is 2x. What is it? What's the derivative of xy when implicit? Can you tell me
X
that?
prime, or it would be y minus x, y prime.
Yeah. Now, do you like y prime or do you like dy dx? Or does it matter?
Y prime.
Okay. Yeah, me too. It's a little faster. Now with the y cubed, it is 3y squared, but there's also a y prime. Now, typically they want you to solve for y prime because it's multiple choice, because they're not grading your work. I would put the numbers in at this point. So I'd put 1 in for x, so 2 times 1 minus 2 plus 1 y prime plus 3y squared, 3 times 2 squared y prime. It's kind of your choice if you want to solve for y prime. I mean, either is fine, but I guess I feel sometimes like, okay, well, I want to get there as quickly as I can. 2 squared is 4 times 3 is 12, 12y prime equals 0. All right, so now the 2's cancel. That's nice. And we are left with 11y prime equals 0. You can combine them algebraically. So this one, y prime, would end up being 0.
Okay. Okay.
Thoughts on that, or do you want another
Yeah, I
implicit?
got that.
Okay. All right, 9 is I don't want to say 9. 9's again kind of it's a good question. This actually is kind of an AP style question because it's not really like pure doing the derivatives. You gotta kind of think through, like, what does it mean when there's a function inside a function? They're giving you this. They're saying if f is always positive differential function, that is not important, but they're just throwing that in. What is important is, like, do you remember the rule for ln when you take a logarithm, or when you have ln? Do you remember how to take a derivative of that?
It's 1 over.
Yeah, the derivative is 1 over x times x prime. Like, you have to take 1 over whatever's inside there, 1 over f sine x. Okay. But there's more. You now have to take the derivative of the inside function. So when you don't know the function, its derivative is f prime.
Okay.
And then you take the derivative of the inside function. Derivative of sine is cosine. And now you have your derivative. Okay. But they're asking you to evaluate it at 4. So you're not quite done. You have to then put 4 in for x. So which would be the correct answer after you do that?
So wait. be 1 over F sine squared. Would be D.
It is D. Now, occasionally what you'll see is they'll choose an X value where you actually can evaluate it. Like you might get something like where X is like pi, and all of a sudden you got to evaluate sine of pi and sine of pi and cosine of pi. So be on the lookout for that. There are some where they actually do work out.
Okay.
All right, let me know when you're ready to go into number 10.
I'm ready.
All right. So inverse trig, there's like sine, cosine, tangent, secant, cosecant, cotangent. I guess they're fair game to give you in the AP. Do you have a table of derivatives and integrals that you like?
No, didn't you send me one?
Yeah, I'll send it to you again. It's really important to have something that you like. I didn't mean to do that and to drop it in the chat. You should always have one that you can pull up. If you're going to take another year of calculus, whether it's next year or in the future, you got to have one of these. Now there's a whole section on these inverse trig ones, and I guess they're emphasized. So if you at least know the form of this one, you will get down to either C or D, because you can see that sine is got a square root in the bottom. Same with cosine. There are some ways to remember this, like if you remember sine, cosine's the negative of sine, tangent, cotangent's the negative of tangent. There's a way to kind of remember these there.
Okay.
But all of these they're really all chain rule. And I guess students don't see this very often in the classroom. What I'm seeing is, but your derivative is really 1 over the square root, 1 minus u squared, whatever you have inside parentheses here, times u prime. Okay, so it's always this X in all of these represents whatever you're taking the sine inverse, cosecant inverse, cosine inverse, etc. In your problem, it's 5x. So it's in your problem, it's 1 over the square root 1 minus 5x squared. That's where the 25x squared comes from. But then you have to multiply by the derivative. What's the derivative of 5x?
5.
5. And that's the difference between C and D.
Wait, so, but the inverse trig functions don't say we need to multiply it by the derivative.
That's right. But every single derivative is a chain rule derivative. Like d du of e to the u is e to the u times u prime. You at this point are supposed to say, oh, if u, the exponent of e, is a function of x, I have to take its derivative.
Okay. Okay.
So I don't know. I don't know how you're going to remember these, but I've given you some suggestions. Sine and cosine pair together, tangent and cotangent pair together. Same with cosecant and secant. You're not going to get it on the free response, but you will get it in a multiple choice. So you got to decide if one multiple choice question is worth remembering all these for.
Okay.
All right. 11. Wow, these are like never ending. Keep going. All right, the function h consisting of 3 line segments is shown to the right if k is a function such that k of h of x equals h of k of x, which equals x. Find the value of k prime of 0. All right, it looks kind of unconfusing. One of the things you might really want to consider doing whenever you see a lines and stuff like this is actually figuring out the slope of each of these. So like this first one is got a slope of 1. That is the derivative. The second one, and you just eyeball this one's 1/2. And then the last one there is 1. I like that style of pen. There we go. Okay. So we want to find k prime of 0.
Mm-hmm.
And we know that k of h of x equals h of k of x.
Mm-hmm.
So we can start by taking the derivative of one of them or both of them, which equals x. So they're asking for the derivative of x. Why? Oh, I'm sorry. The reason they're telling you this, that's a side point. They're telling you this for a different reason. Come back to that. So your derivative of k of h of x is the derivative of the outside function, keep the inside function, times the derivative of the inside function. And then the other direction, if you go for the second one there, h prime of k of x times k prime of x. And we want it at 0. Okay, so we're evaluating one of these at 0. So basically you got to decide if, which one do you actually have? Can you find h of 0, h prime of 0, or are you able to find h prime of k of 0 times k prime of 0?
Okay.
So they're giving you h. You don't know anything about k other than the k of. So I guess I would tell you to go for the h of 0. So notice that the derivative h prime of 0 is a big one. It does not exist right there. There's no derivative at that place. And the reason is because the slope from the left does not equal the slope from the right.
Mm-hmm.
So that's why this answer is here. If it asked it at any other point, we could probably figure it out.
Okay. So is it like undefined?
Yes.
Okay.
There's no limit, the derivative from the left does not equal derivative from the right. So we know that there's no derivative at that point. It's non-differentiable.
Okay.
Oh, and I guess they give you H stuff on the next page. I didn't even notice that, but we were looking for something to get rid of it, and H prime of 0 is that's a good one thing to get rid of. Oh, so I guess F. It's the graph looks the same. I'm looking at the next one that's just part A, but it's got all this other stuff as well with it.
Mm-hmm.
Let me see if I can snip all this in to figure out. All right, so let f be the function defined by f of x equals sine pi x plus natural log 2 minus x. Let g be a strictly decreasing twice differentiable function. The table above gives values of g and g prime and selected values of x. Let h be a function whose graph consists of 3 line segments. So we already had the slopes. You may want to re-grab those. This is slope of 2, slope of 1/2. This is a slope of 1. Find the tangent line to the graph of f at x equals 1. So this one you're just looking at f. Just looking at f. You don't care about the other ones. They must be useful in the second, B, C, D, E parts. So could you try attempt a derivative of f of x here for us, please?
Yeah.
And then we'll evaluate it at 1.
Um. I think, I don't know if I did it correctly, but would it be cosine or pi times cosine pi x
That's looking good.
minus 1/2 minus x?
Yes.
Is
Excellent.
that right?
Yeah, so now you just put the value of 1 in. So it's
Okay.
pi cosine pi times 1 minus 1/2 minus 1.
So we have to simplify, right?
Yeah, yeah. I mean, it's free response now, but you should you should be able to get a number. Cosine pi. I mean, if you need to go to your calculator, you can, but
Is it a negative pi minus 1?
yes. That's all it's asking for. Slope means to evaluate the derivative. Nothing more needed there. Let's see what part B asks. So it could be like a continuation of A. We'll see here. All right, use the equation of the tangent line to the graph of G at x equals 1 to approximate G of 1.2. So really, it's really two parts. They're saying first do this, right? Write the tangent line at x equals 1 and then use it for this. So you've got to go back to what it is that they're giving you for G. So let me snip in the table. Here's the table. So the tangent line, a couple ways to do it. I really recommend, and you'll want to use this in future math courses, is point slope form. And so your x value is 1. What is your y value when x is 1? Well, think of this column as your y values. The g of x are really your y values. So when x is 1, y is 4. So that's your ordered pair. It's y minus 4 equals your slope, x minus 1. Slope means derivative. What's the derivative at x equals 1?
Negative pi minus 1.
We're doing G now.
Oh, sorry.
Yeah, so G, like these are each, they're asking a bunch of questions about these three things, and they're eventually going to mix them up, but this one's just from the table here.
So slope at 1 would be negative 4.
Yes. So y minus 4 equals negative 4 times x minus 1. You can add 4 to both sides. So you have negative 4x minus 1 plus 4. And then they ask you to put in 1.2 in for x. All right, so go ahead and simplify that.
Is it 3.2?
It is 3.2. Good. All right, and no, no multiple choice, but that's still doable. All right, next one here is to find h double prime at -1. So let's go back and figure out what's h. What are they giving you for h? Oh yeah, they're giving you the three graphs. Okay, and you might say, okay, again, like how do I do that? Well, remember the derivative is slope, so we go grab it here. At -1, there's -1. What's the slope of that line?
It goes up 2 over 1.
Yes, the slope is 2, but they're asking about h double prime. So it's like, how do you do that? Well, you have to be able to graph the derivative. So if this is h, the graph of h prime looks like this. It's got a slope, or it's got a, its derivative is of the original is 2. So the slope looks like this at 2. That's the line y equals 2. So that takes care of this first part. The derivative of the second part we said is 1/2. It looks like a line there at y equals 1/2. And then the last one is kind of going up to the right a little bit more. It's 1. Oops, not there. It's kind of there. So notice that the slope of each of these lines is 0. Slope of all three of these lines is 0.
Mhm.
And the second derivative is the slope of the derivative at that point. So this question is really asking for the slope of these three curves down here at the bottom, but in particular, it's asking about this one on the left. What is its slope? It's 0.
Okay.
Part D. All right. Let W be the function defined by g of x over h of x. So the really it probably should have been set up like this: g of x over h of x. They want you to determine the derivative and then evaluate it at 3. What kind of derivative rules are you going to use for something like this?
Quotient rule.
Yes. So could you attempt to do that here for us, please, and let me know what you come up with?
Okay. Can you like bring the chart up?
This is nothing to, this is just your product rule derivative.
Oh, so I got like what, like G prime 3 times H of 3
Okay.
minus,
Minus, yep, minus.
and then the opposite, like H prime of 3, G of 3.
Okay. All over h of 3 squared. So this one requires you to look at both the charts there. So let me grab those for you here. It's really easy to make a numerical mistake here. So you just want to be really careful with the numbers. Maybe not multiply them as you go, just put them into this here. So do you want to give that a try? Let me know what you come up with.
Okay, wait.
All right, so it should look something like this: 3, -3, -9, plus,
So -7 over 9.
yeah, it looks like it's -7 over 9. All right, so we're gonna go ahead and stop right here for the first hour. Stop